So if you see over here, this is the working space on which we work for the geometry part, for the shading part, construction part, or the zoning. If you want to do zoning, we can define. So this is our basic working plane wherein we model HVAC system, we model all the controls or the input and output parameters. On the left, you can see it's a navigator bar wherein we can see all the building blocks. So we can navigate to surface level, we can navigate to window level, or so this is a basically a tree sort of a thing wherein we can keep on exploring it, and it will take us to the as far as we want to go deep inside. And the same output, same thing basically comes into the output part as well once we are doing the simulation output analysis. So if let's say we want to see the what is the property of this window, or if you want to edit this window, so we can come directly to this window and we can change the parameters. And if there is something like for example you want to change something at the global level, then we can change the parameter at the global level. So it gives basically you know a level of freedom at which point you want to make inputs changes to. So if you want to make change to ground floor or first floor or second floor or surface level or at the building level, so that is the level of freedom that design builder gives us. And it's fairly intuitive and very easy to navigate across the building. Okay, so for the working space, so I'll just show you one more thing. So for the activity, so within the activity tab we have all the modules for how the building is operating, what are the operation schedules, what are the set points that we are looking at. So cooling set point, cooling setback temperature, then what are the internal loads. So and what are the occupancy loads, how the occupancy is operating. So we can define the schedules of throughout the year. We can define weekly schedules, hourly schedules. And if we don't want to go into the textual thing, then design builder has a 7 by 12 schedule wherein we can edit the schedule in this format as well. So it's a fairly graphical thing wherein we can define. So for example, if we have an occupancy of 50% or lighting at 70% at this point, so that this we can do. And it will, instead of working on text, we can work on this kind of graphical GUI, graphical modulation of schedules, and design builder offers us this as well. So we it's a tabular format wherein we can adjust monthly and the weekly schedule within this interface. Then there are multiple options. For example, what kind of lighting category is there. So this is basically needed for the ASHRAE baseline generation. But for now, you can see all the internal loads which goes into the building, from occupants to internal gains to lighting, all those things and their operation can be defined over here. And for example, suppose we have a different schedule in zone 1, so we can go to zone 1 and then we can override the default. And let's say I change this thing, so let's say it's a sports lecture occupancy, so then it will change to sports lecture, and this zone will basically behave as per this definition. And the zone 1 which is there in the block 2, it will behave as per the residential definition. So that we can do. For construction, design builder offers us an option to just see in one single pane what kind of construction which we have used. So there is an inbuilt assembly within this which we can use. So if I can just show you, so below grade walls, ceilings, floors, and all these things are built within are are basically within the design builder library data. And this is the ASHRAE baseline data which is there. So we can use the ASHRAE baseline data as well, and once we automate for the baseline, it will automatically take it based on the climate zone. So suppose, let's say if you want to change the wall assembly, so once we click on edit, we can see how many number of layers are there in our wall. We can change it, we can edit it, we can reduce it. And even we can change the properties of the conductivity, specificity, density, or surface properties, and all those things we can do it over here. For because these texture and all these reflectance, emissivity, all these comes into account once we are doing the daylighting simulation as well. and we can even perform the condensation analysis for the layer that we are doing. So it's not a hygrothermal thing, but it's a basic, it gives us a basic understanding of how the condensation analysis will work. Even we can add cost of each assembly, so that can even go once we are trying to optimize the cost within the design, so within the design builder. So this is a level of modularity that we have. So we can perform, we can change any kind of layer, we can change flat roof, we can change wall, then we can see what kind of infiltration will come into our building, so we can just change into it. So for the openings part, then we can similarly we can go to the reference glazing. So we have n number of glazings from ASHRAE baseline database, from double glazing database, skylights. So double glazing, we have multiple options from low E glass. So if you don't want to make it a custom glass, we can just use a specific glass which we think is closest to our number, and then we can, you know, just apply it over here, and it will come over here. And if we want to, you know, manually change it, then we can define the SHGC light transmission and U value in a very simple way, and we can add the cost anyways. And similarly for the lighting, we can define lighting power density. We can define the lighting controls. What kind of lighting controls are there? If it's a stepped control or if it's a linear control. So that kind of thing we can control. We can even define the inputs for the clear control with what kind of then what is the area which is being governed by the lighting sensors. So that we can add within the lighting module. So for the HVAC, we have even so this HVAC tab basically gives us an input into the basic. So I just told you that there are two modules within the design builder for HVAC modeling. So these are all the modules which are there in the for the simple HVAC modeling. And right now, if you see over there, it has been greened out because I am right now into a detailed HVAC module. That's why it's overriding the basic HVAC module. And yeah. So for the generation, we can electric load center I've shown you, but for now I'll just not go into it. I'll just show you how the HVAC module works. So once we come over here, you can see that it's a VRF outdoor unit, which has been connected to the indoor unit of the 3 zones. So we have 3 zones, zone 1 for each block. And hello. And if we want, we can load the HVAC system, and we have the pre-built modules. If I can zoom in into it. So if you see, we have air source heat pump, we have VRF, we have unitary air to air heat pump, so solar assisted absorption chiller. So any kind of possible system that we want, it's already there within the design builder. We can just load that module, and we can import it into design builder, and we can basically model it. And if you want to do it in a custom manner, we can change the controls. So if you see over here, it's an AHU, then this is set point manager, then these are all the fans. So and if you want to go, we can change any kind of input we want. So suppose we want to change the cooling COP, so we can override the cooling COP. Or if you want to have a typical, so for example, we want to have a LGVRF curves, so we can have LGVRF curves. Or even if you don't have any module, if you want to have a custom performance curve, or if you want a custom VRF system, then we can even make our own curves within the design builder, and we can import it into this assembly. So it gives us a, you know, very detailed modularity of what we can do in terms of performance curves, in terms of efficiency and controls, so as to make sure that our system is mimicking the system which has been designed by the HVAC engineer. So we are on a way, you know, our outputs are fairly close to what is expected in the real life scenario. So if I just go over here, so on the top we have all the input parameters, and on the down we have all the output parameters. Okay, so let me just go to daylighting part first and just show you how we can. So I have selected lead version for option 2 for now, and I'll just click OK. So it will just run a basic run, and it will give us an option that if the project is failing, or if it's passing as per the lead version for option 2 or not. It will give a basic output report over here. Similarly, if we don't want a report, we want to see the map. So it will show us the detailed map with the with all the lux level or the daylight factor level for each grid. So we can define this grid. Size of the grid 1 by 1 meter, 1 by 2 meter, whatever you want, and we can export this data out as well for post processing in Excel or any other software that we want. So it gives us a very fair idea of if we are able to comply with the any other. So we have shown you in the presentation that we have lead version 2, version 3. So any kind of software that green building rating system that we want, we can just select this, and it will basically run the simulation and see if it's complying with the requirements of the code or not. Similarly, for the annual simulation, I'm not updating it right now because annual simulation takes slight bit of time. It will take around half a minute, so we'll have to wait for it. So I am not going in that direction, but the process is same. We can so it for the point in time analysis, it will go give us the illuminance map, and in the annual daylighting, we can similarly select all the options for lead and BREEAM, and then we can say if you want to see SDA or ASC, annual sunlight exposure or spatial daylight or autonomy. So any kind of output that we are looking at, we want, we can see it and we can export it, and we can see what we can then again come back to the layout, change the glass, change the VLT of the glass, then again go to the daylighting and again perform the simulation and see if we are able to comply with lead version 2 option credit or not. So in this way, we will be able to make sure that our design does not get stuck at the later stages of the design, but we are basically able to meet the criteria of the code or any other local authority, whatever regulations are there. Similarly, for the cooling design, if for the HVAC engineer, if you want to see what is the sizing of the system or what are the space loads which are there, so we can just click on the cooling sizing and we can click on update, and based on the HA heat balance method, it will calculate the heat load, and it will give us a summary of what is the total design capacity of the system. And for the design day, we can define if we want to size it on multiple design day or the peak design day. So that is the possibility and flexibility that we can do. And then we can go, so if you see at the zone level, what is the air temperature, what is the outside temperature, then what is the total cooling load, what is, and how the heat balance is working out. So if suppose we go to the comfort, it will show us all the parameters of the comfort. If we go to the internal gains, it will show us how the internal gains and the heat balance is working out. And if we go to the fabric and ventilation, it will show us how the heat gain is coming through the fabric and ventilation, through external ventilation and infiltration. Okay, so similarly we can do the heating design part as well. And for the visualize tab, it's a very good tool. Basically it will give us an idea of, so if we click on the rendered view, so we can show sun path diagram. So it will give us a sun path around our building, and we can size it, we can increase the size of the curve of the arc if you want. Then once we click on the show shadows, so if suppose we want to see what will be the penetration of the sunlight within our building at this particular point of time, so we can change the time. For example, if I want to see at suppose 2 p.m. and then 15th of suppose December or October, then we will have an idea of if the daylight will go in or not. Or if you want to see within the peak summer month, if the what will be the impact of penetration of daylight. So if we want, now you can see that at 2 p.m. and on 15 July the sunlight is somehow going into the space. That means we'll have heat gains, or we can still have glares because there is no shading right now. So we can add a shading, and I'll just show you how to do it. We can go to the openings tab. It's a very simple thing. Click on local shading, click 1 meter overhang, and then we have 1 meter overhang across all the windows. We can click on visualize, and now if you see on 15 July to 2 p.m. we don't have the sunlight going within the space. Okay, so based on this, we can even design the daylighting, the shading devices of our building as well. That on the peak summer day or the peak winter day, when we want to cut the sun or we want to allow the sun within the space, we can size our vertical and horizontal shading devices based on that. Okay, and if you want to see the rendered part with respect to the construction, or if you want to zoom into a particular thing, or suppose we want to show it in a section manner, so we can show it to the client that whatever has been modeled in this section, or we can reframe the section to the vertical axis, so we can change the axis, we can look it from the top as well. So and so these are these how we can render it, we can make sections out of it, and we can see how the building looks in terms of geometry. So whatever we have modeled, we can present it to the client in a more presentable manner, and that will basically validate things that we have been doing within the software. Now I am coming to the simulation part. So we have done the cooling design, we did the visualize, we did the daylighting, and how the reports comes out. Once we go to the simulation, we can, so for now we have defined all the inputs for internal gains, we have defined the windows, we have defined the constructions, everything has been defined, and all those most of the things were predefined and the defaults, but and the HVAC system has been defined. So we'll click on the update data, and we'll select what do we want. If you want the annual simulation, we can click on annual. We can, if you want us to see how the building is behaving during summer typical week, we can, or we can manually override which month, from which month to which month we want to run the simulation. And over here we can say select if you want the outputs in daily format, hourly format, sub hourly format, and then even we can choose which kind of output do we want. So if we are doing adaptive comfort, thermal comfort from SRS standard 55, we can click on this. So those outputs will come out. And if you select on store surface output, then the surface outputs will come out in the output tab. So it gives us the possibility of what kind of outputs do we want, and how much heavy do we want our file to be. Similarly, for the annual reports, we can select what kind of output reports we wanted annually, monthly, and then we can even go to the miscellaneous output of what kind of HVAC temperatures are there, what is the amount of flow, chill water flow, what is the amount of heat exchange which is taking place. So all these things we can select, we can choose based on the kind of project we are working and the kind of output do we want. Then we have a simulation manager as well, wherein we can manage all the simulation that we are doing. So once we click on OK, it will generate the thing, and it will perform on the simulation over here. So you can see on this thing, the building name is here, then the file name is there, what time, how much time it took to run the simulation. So from here, what we can do is, so we did an hourly simulation. If you click on this, we can load the result into design builder, and if we click on this, we can export this result into an external tool, which is a basically design builder result viewer, and it's free of cost available. We can import any ESO file within this. So if you see within the summary, it will give us the summary of what is the weather file that we have used, then what is the annual bill, what is the annual bill, annual sorry an energy consumption of the building within the given time frame, what is the building area. So all the summary which we have selected over there, then what is the window wall ratio, what is the latitude longitude of the building, all the input that we have given over there will come in a summary form in the report format over here. So all the construction details, and if we want more details, then we can even go to more details. So what is the sizing of the fan, what is the flow per fan, so all these things will come over here. And even if we go, and if you are basically looking into lead, so it will give us the summary for the lead as well. So if you are specifically looking for lead output, it will give us the output in terms of the lead output summary we want. Okay, and so this is this thing. But since we did the hourly simulation, if you want to see the how the air temperature is modulating across the air, we can click on hourly, and then it will give us all the outputs which are there in this format. Okay, and suppose if I want to see what is the zone air temperature at a particular point of time, so we can click on zone mean air temperature for block zone 1, and it will show us the temperature. So on the vertical axis you can see it's a temperature, and on this thing you can see these are the for July 3rd to July 9th. So we didn't run the annual simulation, we run the simulation for these 7 days only. So if you can see, if let me just zoom in over here. So once the building is occupied from 9 to 6, the temperature is being maintained as 26, and over here the temperature is been maintained at 32. So if you remember, if I just go back to the activity tab of the building, we have defined the cooling set point as 26 and cooling set back as 32. So this is the same temperature which we have got in output. Uh, since because the controls and the system sizing is correct, so that means we are able, the system that we have designed is able to meet the temperature that we are looking at. Okay. Similarly, if we basically want to see what is the uh, overall electrical profile of the building, okay, so then we can close this thing, we can remove this chart, and we can, so we can even say what is the zone operative temperature. So there is a difference between air temperature and operative temperature of the zone is taken, it's an average of sort of average of air temperature and mean radiant temperature. So that we can see what is the impact of insulation. So what is the mean radiant temperature within the zone. So so if you see, it's fairly higher than what the air temperature was, because system is controlling thermostat is on the air only, but over here the surface temperature is still going high. So if you are doing thermal comfort analysis, we can see, okay, oh, if even if the air temperature is this much, maybe the occupants will not be comfortable because the surface temperature is very high. So these kind of we can even plot the relative humidity within the space. Okay, so these are different outputs which we can even plot what is the part load ratio on which the system is running. So the possibilities, are innumerable. We can, it depends on what we want, and what we are designing, what kind of system we are optimizing. So we can take this output daily as well, we can take it monthly or throughout the run period or hourly. And and if I just show you, if you don't want an external software, if you want to just use the outputs, you want to see the outputs in the design builder, you can just click, uh sorry, I just ran too fast. So click on here, and if you go to this to load results into design builder, all the outputs that you are looking over there, basically they have come into design builder. So from here, it gives us a flexibility that we can choose which zone or which level we want to see the outputs at. So if you want to see the wall outputs, so there are no wall outputs because I have unchecked the surface output, so there are no surface output right now, but the outputs are available till zone level also only. So at zone level we have, comfort outputs, internal gains, whatever was there. So all these outputs are within the, we can use this navigation bar, and we can select at, if you want to see the output at building level or zone level, whatever you want. Okay, and then we can again go to detail mode, and we can add more outputs if you want, and if it's not coming in the default output tray, so that when we can perform. So in this way, it's one of the few software wherein you can perform the HVAC simulation, daylighting, cooling sizing, and all the controls for HVAC. Then you can perform costing, solar PV you can model, and we can even perform the parametric analysis. So this is, very one of the very few software wherein all these things can be performed. I think with this, I rest my case for now. This is the brief summary of what we can done. So the software is very huge, and the outputs are very huge. So let me just show you one more thing. So if we click on this thing, generate baseline building, so it will say ASHA 90.1 standard applies to, and so it basically gives us a pop-up if there is something which is not going as per this thing. And once we click on next, it will generate the baseline building. So we don't have to apply the construction, we don't have to apply the baseline parameters. It will basically be as per the ASHRAE protocols, it will give us the baseline building. And if you see over here in the construction part, all the ASHRAE baseline constructions have been applied within the baseline building. So we can then model the HPC system, and our work got reduced to half in a way. I think Shami, this is from my side for now, because the time is now running out again. And the modules are still left, but I think this is more than enough for, if we can have some queries, we can just answer.
Sure. If somebody has any query in this regard, what we have presented right now, they can ask by unmuting themselves.
Any query related to HVAC or daylighting or anything related to the possibility of geometry, construction creation, or editing of properties, anything if you want to ask, or if there is something.
Hello, can I ask about the energy? Can we also have some data about energy usage, energy savings?
Mm-hmm.
For energy saving, is there like some data that we can get from the software?
Yeah, so if I show you this output, so within the summary, if you see, this is the total energy consumption which is for the 1 week. Okay, and the split of this is that the cooling consumption is this much, lighting is this much, and equipment is this much. Okay, so this split we can get within the different end uses, or if we want a detailed kilowatt output of this, we can go to lead summary, and then here it will show us what is the peak kilowatt hour and what is the peak electricity demand for that particular end use. So this is how we can, and if you want to compare it with another suppose ECM, then we can change that particular ECM, and then we can rerun it and to see what is the impact of that thing with on the cooling demand or lighting demand or whatever end use that we are trying to modulate or optimize.
Thank you.
Yeah. Okay.
I think.
Assalamu alaikum.
Yeah, please.
Yeah, I have a question. First, thank you for this lecture. Is it possible to simulate the renewable energy for building, such as solar panels or wind turbines?
So I've shown you over here in the presentation as well that we can define even the PV array, we can define the electric load centers, and we can go to the parameters of the inverter, what kind of inverter is there, what is the losses. So all those things we can model within the design builder, and we can even integrate the demand side and the supply side. So that can be done, and we can manually model the PV array as well. So if I show you this, if you can see over here, so these are the PV modules which the modeler has done. So we can take the impact of shading as well. So it basically it's a opaque object, and it's the construction is basically the same as the PV module, and it gives the total impact in terms of the shading on the roof as well, and we can have the generation output as well. So if you see the photovoltaic power in the output, it shows us what is the total generation from the photovoltaic or the wind, or what is and what percent is it for the total energy end use.